Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about random access interface. In this video I will explain what is the purpose of random access interface. So without wasting any time, let's get started. So guys, let's begin this video with this collection hierarchy. So if you look at this collection hierarchy, you will see that there are two collection classes that implements list interface, and these are ArrayList and linked list. And guys, if you look into the source code of these two collection classes, you will see that ArrayList implements random access interface, whereas if you go to check linked list source code, you will see that linked list does not implement random access interface. So why is it so? What is so special about random access interface that only ArrayList is implementing this interface? So in today's video, we are going to deep dive into the reasons why ArrayList implements random access interface. So in order to understand random access interface, let's jump over to random access interface source code. So this is the source code of random access interface. So you can see that interface belongs to java.util package, and this is just an empty interface. So whenever we see an empty interface, we immediately come to know that this is a marker interface. Okay, now so far so clear. So this brings us to the next question, that what is the purpose of this random access interface? So in order to understand the random access interface, I have to tell you a story. Okay, so let's begin. So let's say one day you are working on a project and your task is to write a generic algorithm that takes a list collection as an argument and print all the collections in the list in reverse order. So what you did, you wrote a function public static void, and name of method is, let's say, algo, and this method is taking a list as argument. Okay, list of L as argument, and now you started writing the algorithm. So guys, as we all know that there are only two types of collection that implements the list interface. One is the array list and one is the linked list. So in worst case, you assume that you might get linked list as a collection. So what you did, you wrote an algorithm that traverses all the elements from one to last and prints all the element one by one. This was your task, and you are done with writing an algorithm. And after writing an algorithm, you went on to run the algorithm by providing a list collection. Okay, and you will realize that this algorithm is not at all efficient and it is taking a lot of time, and probably it consumes all of your RAM. For example, let's say the list contains thousands and millions of elements, then what would be the performance of your algorithm? It will drain your memory. Okay, it will simply drain your memory, and this is also possible that your application may crash. So these are all the possible things that could happen. So in order to solve this problem, what could be the solution? So to understand why this is happening, let's head over to Notepad. So guys, let's assume you are getting linked list as a list collection. Okay, and you already know that how linked list works. Linked list consisted of nodes. This is first node, this is second node, this is third node, and so on and so forth. And we are assuming that we are getting a lot of elements in the collection, for example 1000 and 1000. So in linked list, first node is pointing to second node is pointing to third node. And if you consider the arrangement of all the nodes in the memory, you can see that this is your memory. First node is stored in this memory location, second node is stored in this memory location, third is there, fourth is here, and so on and so forth. Now if you have to access the last element of the linked list, you have to start from the first node, then moving to second node, then third node, and all the way to last node. Okay, and then let's say if you want to access the second last element, then again you have to start from the first node, then go to second node, then go to third node, and so on and so forth. And we have assumed that we have thousands and thousands of elements. So if you do this process, then you end up consuming a lot of resources, right? Because to print all the elements in reverse order, you have to start every time from first element to reach the last element, and then second last, and then third last, because in linked list we can only traverse in one direction only. But guys, let's assume that in best case, what if you get ArrayList as input? And if you know about ArrayList, you will know that in ArrayList, elements are arranged in sequential and contiguous memory location. So let's say this is the memory, and your elements are arranged in sequential and contiguous memory location. And what if we have to access the last element? You can simply access the last element in constant time. Yes, this is the property of ArrayList. As the elements are arranged in sequential and contiguous memory location, we can access any element randomly in a constant amount of time. So do you see the difference? If you have to print all the elements in array list from last to first, you can access all the elements in constant time. So if there are 5 elements, your time complexity will be 5, big O of 5. But in case of linked list, if you have to print all the elements in reverse order, first you have to make a traversal from first to last element, then again you have to make a traversal from first to second last element, then again you have to make a traversal from first to third last element, so on and so forth. You can imagine that how much time you need to traverse a linked list type of data structure from last element to first element. So this is just a hypothetical situation I am taking just to make you understand that what is the difference between a linked list type of data structure or array type of data structure. So guys, if I tell you that if there is something by which you can know in advance that which type of list data structure you are going to take in your algorithm, then what would be your thought? Obviously, if you know this information in advance, this is going to be a game changer, right? How? Let me show you. So when you are writing algorithm, so what if you can do like this? Let's say the list you are getting is of type array list, okay? If you are getting array list, then you can write some other logic, okay? And that would be your efficient logic, okay? And in worst case, if you are not getting list, let's say the list you are getting is of type linked list, then you can do your normal stuff, okay? But in best case, you can reducing the time complexity of your algorithm to a significant extent, right? So guys, this is the actual problem where random access interface comes into picture to rescue us. And what it does? So the purpose of random access interface is just to inform that this particular collection supports random access and fast access, so that whenever we write generic algorithms, we can simply switch the implementation based on the type of collections we are getting, okay? And how do we do it? It's pretty simple. Just we have to check if a list we are getting is instance of random access. So this means if we are getting array list that implements random access, then our logic would be different, okay? And in case if we are not getting any collection that implements random access, then our logic will be different. So this is the main purpose of random access interface, to just inform and notify that the particular collection supports random access and faster access, so that we can switch the implementation based on the collection. So guys, by now I hope you understood what is the actual purpose of random access interface and what problem it solves. So guys, if you have learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming video. So this is all from my side. Thanks for watching. See you in the next one.